In today's class, we are going to talk about the product rule of differential calculus and when and how to use the product rule of differential calculus. Product rule of differential calculus is used when we are told to differentiate a function that has two parts and these two parts are multiplying each other. For example, if you are given a function y is equals to uv, you can see u is a part of y and v is also a part of y. The sign between u and v is product. In that case, we employ the product rule of differential calculus to differentiate this function. So the product rule states that the derivative of y is equals to u multiplied by dv plus v multiplied by du. This is the product rule formula. If you are told to differentiate a function that has two parts, we differentiate the function as this. Since you have known when and how to use the product use formula, let us apply the product rule formula to differentiate the following function. Let's take question number 1. We have y is equals to 2x plus 3 into bracket x squared plus 4. Y is equals to 2x plus 3 into bracket x squared plus 4. Now, to differentiate this function, the first step is to identify your u and v. Don't forget that from the product rule formula, y is equals to uv. The derivative is what? U multiplied by dv and plus v multiplied by du. Now, comparing this function with this function, you can see that u is equals to 2x plus 3. So, u is equals to 2x plus 3. And v, which is the other part of this function, if you compare it with this function, v is equals to x squared plus 4. v is equals to x squared plus 4. Okay, now from the formula, you can see that we need the derivative of v and the derivative of u. Therefore, I'm going to first take the derivative of u, which is u prime is equals to, if you take the derivative of u with the using the first principle, the derivative of 2x is what? 2. And if you take the derivative of v, which is x squared plus 4, the derivative of v using the power rule is 2x. So, I have gotten the derivative of u and v. Now, the next step is to just substitute all these parameters into this formula. Now, let us proceed. The derivative of y is equals to u is 2x plus 3, that is 2x plus 3, multiplied by the derivative of v. And the derivative of v is 2x, that is multiplied by 2x. Let me put it into bracket. Plus v plus v. V is x squared plus 4. That is plus x squared plus 4 multiplied by du. Du is what? Du is 2. You can see, multiplied by 2. So, let us open the bracket. So, I'm going to have the derivative of y is equals to 2x multiplied by 2x. That is 4x squared. 4x squared. 2x multiplied by 3. That is 6x plus 6x. Put it in the bracket. Now let us open the bracket. 2 multiplied by x squared, that is 2x squared, plus 2 multiplied by 4, that is 8. So the derivative of y is equals to, if you open this bracket, you can see that we have 4x squared plus 2x squared. Let us open the bracket. 4x squared plus 6x plus 2x squared plus 8. Okay, we can have y is equals to, or let's like times 4x squared plus 2x squared, that is 6x squared. 6x squared plus 6x plus 8. So therefore, we have taken the derivative of the first question. Now let us proceed to the second question. 2, we have y is equals to 2x squared plus 4 into bracket x raised to the power of 3 plus 1. The first step is to identify your u and v. And if you compare this function with this function, you can see that u is equals to 2x squared plus 4. 2x squared plus 4. And v, which is the other part of this function, is equals to x squared, x raised to the power of 3 plus 1. Okay, the next step is to take the derivative of u and v. So, the derivative of u, this can also be written as the u all over the x. So, don't be confused. I just don't want to put it. You can also write derivative of u as du over dx. So let's see it. The derivative of u using the power rule is 4x. Probably you didn't know how to use the power rule of the differentiation. You can proceed back to the channel and watch video on how to use the power rule of differentiation. Okay, take the derivative of 2x, so you are going to get this. So the derivative of v is equals to 3x raised to the power of 2. And the derivative of constant is 0, so there is no need of writing that. Now, the next step is to substitute all these parameters into this formula. So the derivative of y is equals to the derivative u, which is 2x squared, 2x raised to the power of 2 plus 4, multiplied by the v. Derivative of v is 3x raised to the power of 2. That is 3x raised to the power of 2. Then put another bracket, additional sign, plus v is x raised to the power of 3, x raised to the power of 3 plus 1, multiplied by derivative of u is 4x, so multiply by 4x. So the derivative of y is equals to 3x raised to the power of 2 multiplied by 2x raised to the power of 2. That is 6x raised to the power of 4. 3x raised to the power of 2 multiplied by 4. That is 12x plus 12x raised to the power of 2. Okay, let's proceed. X raised to the power of 3 multiplied by 4x. That is plus 4x raised to the power of 4 plus 4x multiplied by 1. That is 4x plus 4x. Okay. So if you collect like terms, the derivative of y is equals to 6x raised to the power of 4 plus 4x raised to the power of 4. That is 10x. 10x raised to the power of 4 plus 12x raised to the power of 2 plus 4x. So the derivative of y is equals to 2x squared plus 4 into bracket multiplied by x raised to the power of 3 plus 1 is this. The summary of product rule is this. When you are told to differentiate a function that has two parts, you employ product rule. And to differentiate such function, the first step is to identify your u and v. Then you are going to take the derivative of u and v. After that, you are going to substitute the parameters into the product rule formula. Thank you very much for watching the video. Please, I would like you to subscribe to my channel and hit the notification bell so that when I drop new video, you are going to get updates.